on to the last speaker for today's session, who is Dr. Tejal Gajaria. So Dr. Tejal is an algae enthusiast working as assistant professor at the Division of Biomedical and Life Sciences, School of Science, Navrachana University, Vadodara. She received her doctorate from the Central Salt and Marine Chemical Research Institute of India. Her work is focused on algal biochemistry and bioprocessing. Her research is rooted in developing indigenous seaweed bioprocessing methods for Indian as well as global algae-based commodity market, such as dietary proteins, carbohydrate, prebiotics, etc. Today, Dr. Tejal will share some of her research in Sorry, I didn't know the title of the talk. So please, the floor is yours, Dr. Tejal. Sorry about this.
Good evening. Hello to everyone who have joined. Am I audible, Professor
Yes,
Hema?
you are. Yes, you are.
Thank you for kind introduction. So I'm just sharing my screen. Just let me know if it is visible to all of you.
Yes,
I
it
hope
is
it is
visible.
visible.
Yes.
Yeah. All right. So good evening, everyone. Good evening from India. Everyone, and hello to all who have joined from different localities, different regions. So my title of the talk is biorefining of seaweed proteins, and here we are comparing quality versus quantity. So if we talk about biorefinery concept, it is meant to provide enhanced sustainability to the processes which have been developed so far, or to make uh, betterment into the existing processes. And the process is considered as more efficient if we are able to extract more than one, or let's say more than two, commercially valuable commodity materials from the biomass. Now, for seaweeds, we have one more added advantage over here, because if we are using cultivated biomass, so we are not only sequestering atmospheric carbon dioxide, but we are also providing livelihood to the local populations who are living in to the coastline. And India is blessed with the largest coastline in this region, about 7,000 kilometers. So efforts are underway to strengthen more and more people so that they can take advantage of this new blue economy. They can be part of the blue economy. So let's delve into the process. So here in our lab, when I was working as a PhD student at CSMCRI Bhavnagar, India, so we have developed alkaline hydrolysis-based protein recovery using the biorefinery concept. In this process, other than protein, I was also able to isolate 4 other products, which are mineral salts, sulfurate polysaccharide Ulvan, crude lipids, and as well as cellulose. So here in the bar diagram, I have tried to explain the process efficiency at each and every step, and how each and recovery of compounds were aligned such a way so that we lose minimum protein during the extraction of minerals or lipids or sulfated polysaccharide, and maximum extraction is obtained during the protein extraction step. So our product recovery was 11% percentage of the derived biomass, and the process efficiency was nearly 68%. Now there are, in addition to the extraction processes over here and obtaining crude protein hydrolysate over here, we also try to analyze the co-precipitation or chances of accumulation of heavy metals for in the extracted protein. So over here we analyzed, other than keeping aside mercury, all the heavy metals were far below the range provided by recommended range provided by FDA and WHO. In addition to that, you can see at the graph in figure 2 over here, we have tried to compare the amount of essential amino acid present in our biorefinery extracted protein, wherein cysteine and methionine and also tyrosine, they were degraded during the sample preparation of HPLC. So we are also working on better HPLC methods, wherein we can obtain cysteine and methionine as well. But you can see over here, most of the amino acids were far comparable or far above the levels recommended by WHO, except leucine and lysine. So and they can also, because we believe these variations are dependent on seasonal, because India being at the tropical line over here, so seasonality, particularly monsoon season and summer season, they impact biomass quality a lot, significantly. So followed by the analysis of heavy metal, the second most important component was to check the possible cytotoxicity of extracted protein hydrolyzed. So here we have done in vitro analysis using animal cell line, non-transformed normal animal cell line, and we compared the results with standard casein protein. So here, the protein did not show any cytotoxicity in this MTT-based assay. And also, the in vitro digestibility was assessed by ophthaldehyde assay, in vitro OPA assay, which shows the digestibility in terms of percentage of degree hydrolysis. So here also we compared the degree of hydrolysis using the standard protein, that is casein. So the digestibility was fairly comparable with casein, and which ranged around 85 to 86% of the casein hydrolysis. So the proteins were found highly soluble, digestible, and free from heavy metals as well as any potential toxicants which might impact the what we say um, its edible application. Now these were the preliminary studies what we did, and I came across two possible areas wherein rate limiting factors were playing very important role. So first aspect was bioprocessing. Now these are the marine biomass, and to survive in the marine environment, they accumulate a lot of organic osmolytes, which also includes sugar. In addition to that, they also produce numerous secondary metabolites. All these factors play, or let's say they interfere protein extraction from the biomass. In addition to that, in the other aspect, that is the yield. Now, yield is also impacted by the seasonality of the biomass, in which season we have taken the biomass for extraction procedure, and also the life cycle of alga. So these were the crucial points to be determined before carrying out the process. Now these were seen under laboratory conditions. So these impacts may multiply if we go ahead in pilot condition at pilot scale. So it is very imperative to understand these parameters crucially, going ahead for pilot scale or industrial scale isolation of proteins. So now here we discussed about the crude extraction of proteins, seaweed proteins. Now in this protein hydrolyzed, there might be number of compounds which interfere or which impacts the purity on the basis of amino acid scale, as the previous speaker discussed. These purity of proteins are very important. Purity of protein is a very important parameter, specifically when we want to commercialize the product. So we need to say the purity ratio, we need to talk about the amino acid score, the digestibility score, and for that we need to bring about the enrichment from the crude hydrolysates. So basically we perform proteins can be enriched using these three physicochemically distinct processes. So isoelectric precipitation, which is based on the pH change, salting out, which is based on the removing water molecules using any salt. Let's say ammonium sulfate is the most routinely used salt, and aqueous two-phase partitioning, wherein we use two different solvents. Now, we analyzed we analyzed the impact of enrichment using these three processes on the functional properties as well as physiochemical properties of the proteins. Now, these properties are very important when we are intending these proteins to get incorporated into, let's say, dairy food, or let's say baked items or ice creams or any other edible items, wherein they play a crucial role in the uh, uh, formulation. That's very, very important, because when we intend to market anything, when we intend to bring some new ingredient to public, so its appearance, its taste, its palatability, malleability in mouth, everything plays a very crucial role. So before diving into the results, I just wanted to give you an overview about how the chemistry of amino acids contributes overall to the properties of protein. So amino acids are classified on the basis of their hydrophobicity, hydrophilicity, their nature as aromatic, aliphatic, the acidic or basic, and all these characteristics are provided by the side chains of amino acids. So ionic interactions, hydrogen bonding interactions, van der Waals interactions, and even sometimes covalent interaction happen between these two side chains, and they promote uh, binding with the other ingredients, let's say in baking, in making of bread, okay, in mixing with ice cream or in gel-based product, anything. So they are very crucial. The enrichment method play a very crucial role uh, when we think about the sensory properties and all. So if we look at the results, the salting out method wherein we are using ammonium salts, it provided the highest enrichment of proteins, and followed by the isoelectric precipitation. Here, isoelectric precipitation was done using two different acidic molecules, one diluted HCl and one trichloroacetic acid. In most publications, we also came across the use of trichloroacetic acid. So we also checked both uh, the acids for their effect on the precipitation of proteins. In the other graph in figure 7 over here, now it's not only protein which is important when we are doing enrichment. Here, whether during enrichment any other co-precipitants are present, such as secondary metabolites or sugars or carbohydrates, low molecular weight carbohydrates. So yes, we were able to detect total carbohydrate in all the fractions, as salting out was very much efficient in precipitating, or let's say in concentrating proteins from crude hydrolysate. It also showed more amount of carbohydrates compared to isoelectric focusing and aqueous two-phase partitioning. Now, the effect was also evident on their antioxidant properties. So here in figure 8, you can see DPPH free radical scavenging activity, wherein isoelectric point and SO, they both showed somehow more or less comparable free radical scavenging activity, but the results were quite different in the reducing activity. As you can see, salting out remained the highest activity showing fraction, but aqueous two-phase partitioning protein fraction showed considerably higher amount of reducing potential compared to isoelectric focusing fraction. So that was the notable observation for us between both the activities. Followed by that, we analyzed the presence of, we tried to understand what is the nature of crude proteins present in our samples. So here we were able to detect the presence of amide bend in FTIR, that is in figure 10. In addition to confirmation of amide bends, we were also able to find out the presence of sulfur groups, which might be contributed by either sulfur-hydryl groups from cysteine or methionine amino acid. And in addition to that, that might be the possibility of the presence of Ulvan, which is also sulfated polysaccharide in Ulva. Now, in physico-chemical parameters, surface hydrophobicity, foaming capacity, foaming stability, as well as these three parameters were reported highest for the fraction of salting out. Now, surface hydrophobicity is the parameter which plays crucial role when we talk about bioavailability, biodigestibility, as well as bioaccessibility, because this parameter shows the access of functional groups to interact with the probe. So we are using a probe, and with the help of probe, we are able to assess the availability of functional group, which is reflected in the spectrophlorimeter. So that was one of the most important parameters. So that shows if we want to incorporate our proteins for dietary application, and we need good emulsifying activity over there, or what we say, very good malleability activity over there, we have to come across with the approach of salting out proteins enriched by using salts, let it be ammonium salt or any other salt. But this shows the availability of functional groups which can be used to explore uh, uh, like different uh, preparation of different culinaries and all. So, however, in water holding activity and oil holding activity were quite different. So here for water holding activity, aqueous two-phase partitioning fraction showed highest activity, and in oil holding capacity, isoelectric fraction showed highest capacity. So that those were the notable uh, observations over here. One more observation is missing over here. That is the solubility of protein. So solubility of the fraction was highest for salting out proteins, followed by isoelectric fraction proteins and aqueous two-phase partitioning proteins. So solubility plays crucial role when we are particularly making some liquid beverages, some juices like that. So coming to the third and important aspect when we talk about quality of proteins is their interaction with anti-nutritional compounds. Now, anti-nutritional compounds are those compounds which bind with nutritional compounds and inhibit their activity. So nutritional compounds, so here we are focusing on proteins, so I will not dwell on the other nutritional compounds, but you can see over here in anti-nutritional compounds, tannins, phytates, trypsin and amylase inhibitors, mean digestive enzyme inhibitors and glycosides, they are considered as anti-nutritional compounds. And we analyzed different red seaweeds, brown seaweeds, and green seaweeds for the presence of different anti-nutritional compounds. And this is the correlation chart of between all combinations. You can see at the right side of the screen, the component, the combination two, that is the correlation between phytic acid and protein was found positive for all three algal domains, for red algae, for brown algae, as well as for green algae. The other correlations such as phytic acids with tannin, phytic acids with carbohydrate, and tannin with protein, they varied differently among all different groups. So this showed the protein bioavailability of the extracted compound can be effectively limited by the presence of phytic acid in the particular seaweed. So whether we are making a protein hydrolyzed or we are enriching our fraction, we have to make sure we have minimum amount of phytates co-precipitated by whatever method we are using for precipitation so that we can get best possible activity in vivo as well. So phytic acid particularly, it is not good because it binds irreversibly with iron and zinc, so limits their absorption, and it effectively cross-links with the protein, so inhibits the total availability. So here we did one small experiment. We eliminated phytic acid using 70% methanol. So we analyzed activity, the digestibility of 11 different seaweeds belonging to three major domains of the seaweeds. And we analyzed digestibility before and after of the solvent extraction. So as you can see, the inner circle is the digestibility measured by OPA assay, ophthaldehyde acid. It is less compared to the activity which is shown in the outer circle. So that shows the digestibility after giving the solvent treatment. So effectively removing the phytate from the fraction, and the digestibility was measured again by OPA assay. So for all the seaweeds tested over here, all the 11 seaweeds tested over here, the digestibility was significantly increased in the absence of phytate. So that also gave us a very crucial point over here to consider proteins, enrichment of proteins for edible applications. So so if I talk about the key takeaways of my today's talk, so in vitro digestibility for dietary application, if we are intending protein extraction for dietary applications and directly incorporating them into, like, let's say ice creams, baking items, dietary dairy items, etc. In vitro, their digestibility is one of the most important parameter. The digestibility is controlled directly by the phytic acids. Even tannins can also bind covalently with the proteins and they inhibit their bioavailability. The digestive enzyme inhibitors, they play indirect role over here. for the proteins if they get co-precipitated with the protein hydrolyzed, ultimately contributing to the bioaccessibility, bioavailability, and overall functionality of the protein hydrolyzed, which is very important from the sensory point of view assays. So with this, I conclude my today's talk. So thank you everyone for your patience, for understanding, and for your time. And I'm open for the collaborations, national as well as international collaborations. So we can, if my work interests, then we can go ahead and we can talk.